Hi everyone. Today we are going to learn about mycolactone extraction. Mycolactone extraction. Mycolactone is a lipid toxin which is produced by a bacteria. And that bacteria is a Mycobacterium, which is called Mycobacterium ulcerans. Mycobacterium ulcerans. And this Mycobacterium ulcerans in this presentation is going to be abbreviated as MU. MU. So the MU or the Mycobacterium ulcerans is grown in a cell culture bottle which is sterile as indicated here with the red cover, and the media is M7H9 which has been supplemented with OADC. And once the organism grows, it's mostly at a temperature of 32 degrees, and once it grows, we then aliquot a sample of it, spin it, pellet the bacteria, and then to ensure that it's a pure culture, we put it on a slide, and then air dry it, heat fix, and then use Zetten staining to determine the acid fast bacilli. If there are other Kuka staining, then it means it was contaminated and we may have to do away with it. But once we find pure acid fast bacilli, then we are good to go. So in this case, we presume that you've got a pure culture. So you just aliquot a volume of it into an Eppendorf tube and just spin it down to pellet the bacteria. You remove the supernatant and then you just dry the pellets. Once the pellet is dried, you subject it to organic extraction, where you use organic solvents like chloroform and methanol in a ratio of 2:1 to get your organic separation, where you get your organic layer, which is supposed to contain your lipids. You get your proteinaceous layer and then the aqueous layer. But since mycolactone is a lipid, we expect it to be pelleted in the organic layer. So once you add your solvent system to the dried bacteria, you allow it to stand for about 2 hours, after which you then spin for about 15 minutes at 10,000 G. And once that is done, you can then aliquot and discard the supernatant, which is the aqueous layer and the proteinaceous layer. And the organic layer, which is of interest, is then dried. So once the organic layer is dried, you then want to add iced cold acetone to it to ensure that you precipitate any phospholipids. And once phospholipids are precipitated by spinning, you then aspirate your supernatant, which is going to be lipids that are soluble in the acetone. So you just aspirate it and then you put it in a brown bottle. And brown bottle because the mycolactone, if it's presumed to be part of or to be solubilized in this acetone, is light sensitive. So you just ensure that you put it in a brown bottle to prevent degradation. And once our acid soluble lipid has been obtained, you can then spot it onto a TLC plate, and that's a silica gel plate. With a silica gel plate, you have to draw your line of origin and then your endpoint line, and then you, using capillary tube, you just pick a volume of the acetone soluble lipid and then spot it on the line of origin, not forgetting your standard. And once that is done, you then you then put the silica gel plate into your solvent system, which will be comprising of your chloroform, your methanol, and then water in a ratio of 90:10:1. And once you find the migration of the solvent system across, always make sure that the line of origin is above the solvent system. You find it migrating till it gets to the end point, then you remove it. Once you remove it, you allow it to dry, you put it in the UV light. Under the UV light, using a pencil under the UV light, you circle the lipid length, the length of the lipid. You circle the lipid which had migrated, circle it, and then you come out and you draw using a ruler. You try to get the length from the line of origin to the point where the lipid migrated to, and use that to calculate your RF, which is the retention factor. And we know that mycolactone has a retention factor of 0.23, which is going to be your standard. So comparing it to the standard, if you get it at the same, you get the same RF, then it means that lipid that was migrating was mycolactone. Thank you very much. If you have any questions, please comment and subscribe as well. Bye.